Welcome to the next topic. Principle of superposition. In the previous class 1 you might have seen how Coulomb's law formulated the interaction between 2-point charges. From this the force of the charges between 2-point charges were calculated with this formula as shown in the screen. Now instead of 2 charges, more than 2 charges act around a single charge. So the force on one charge due to all the other charges has to be calculated. So how to calculate the force on a charge where more than one charges are acting on it? Consider a system in vacuum of n stationary charges q1, q2, q3, up to qn. For one charge q2 which is acting on charge q1, the force can be calculated by the Coulomb's law formula. But for multiple charges q2, q3, qn acting on q1, what is the force? Here Coulomb's law alone does not have the answer to this question. Now let's work out to find out the force when multiple charges acts on one charge from different directions. Let's consider a system of only 3 charges q1, q2 and q3. When q1 is acting on q2, we get the force as where vector r2, 1, is the unit vector from q2 to q1 along the line joining the 2 charges, and r2, 1, is the distance between the charges q1 and q2. Now the force on q1 exerted by the charge q3 is where vector r3, 1, is the unit vector from q3 to q1 along the line joining the 2 charges, and r3, 1, is the distance between the charges q1 and q3. Thus the total force F1 on q1 due to the 2 charges q2 and q3 is F1 is equal to F1, 2 plus F1, 3, which is k into q1, q2 into r2, 1, vector divided by r2, 1, square, plus k into q1, q3 into r3, 1, vector divided by r3, 1, square. So now the calculation of force can be made generalized to a system of charges which is more than 3. As shown in the figure. Here the principle of superposition is applied here. Because Coulomb's law alone does not support it. The principle of superposition explains the interaction between multiple charges. According to this, the principle of superposition, the total force acting on a given charge is equal to the vector sum of forces exerted on it by all the other charges. Now consider a system of n charges, namely q1, q2, q3, qn. Then the force acting on q1 is F total is equal to F1, 2 plus F1, 3 plus F1, 4 plus ... up to F1. n. So substituting Coulomb's law formula for all the F, we get like this. See here k and q1 does not change. So we take them out and write it by summing up by means of parallelogram laws of vector addition. So the final formula for all the forces acting on one charge is this, where q1 divided by 4 into pi into epsilon 0 is k. Without the principle of superposition, Coulomb's law will be incomplete when applied to more than 2 charges. Both the principle of superposition and Coulomb's law form the fundamental principles of electrostatics, but they are not derivable from each other. So to conclude, the principle of superposition states that the total force acting on a given charge is equal to the vector sum of forces exerted on it by all the other charges. Hope you might have understood the concept. Stay tuned for the next video. Thank you.